Okay, so we've talked about the reason we have simulation, which is to address or account for uncertainty, or randomness, or variability that we are uncertain about in the model. We've talked about how we can represent that variableness, that randomness, with these different variable distributions. We've talked about 5 of them. And we've done a simple or a straightforward example provided for us. So let's talk about one more example and how we would do that. And in this case, we'll actually make use of 3 of our different random variable distributions. Okay. So in this case, we are an consumer electronics firm. We produce battery rechargers for cell phones. Okay. So we have some price at which we can sell these battery chargers, but we're uncertain what that price will be. That is, we haven't determined yet exactly how much we're going to charge. That may depend on a number of external factors and marketing and other things. But we do know that the price will be somewhere between $18.95 and $26.95. So that's kind of the minimum and maximum amount we would sell them for, with a most likely value of somewhere not quite in between, but close of $24.95. So we'll use a triangular distribution to represent the price at which we sell the battery rechargers. Okay, so that's how much we can sell them for. How much we have to pay to build and make them, the cost, is another aspect of uncertainty, and we'll use an uniform distribution to represent that. Minimum $12, maximum $15. So in the worst case, you can imagine it costs us $15 to build the unit, but we only sell it for $18.95. So we only make a profit of $3.95. It's sort of the worst case of those two. In the best case, right, the cost is low and the price is high, and we would make $14.95, right? So in the real world, though, we're not sure where we're going to lie in between those two possibilities. Somewhere in between, likely, with a sort of probably not the best case of cost or the worst case, but not the best or worst case of profit or price that we sell for. But we need to know how many things we sell in order to figure out what profit we'll make. However, the quantity we sell is based partially on the price. That is, the more we charge for the units, the less of them we sell, because the higher the cost to the consumer, the more there's some consumers who just wouldn't buy the product if it costs too much. So we imagine the quantity sold is something like a base 10,000 units minus 250 units for every dollar of price. So if the price goes high, the quantity we'll sell is much less than $10,000 or 10,000 units. However, if the price is somewhat lower, on the lower end, say $18.95, then the quantity we'll sell is not as much less than 10,000. Okay, so 10,000 minus something, 250 in this case, times the unit price. So the more cost to the consumer, the higher the price we charge, the fewer of them will sell. Plus, so we're going to add to that another random term, just to kind of represent randomness in the market. Right? Sometimes people are in the mood to buy battery chargers, regardless of the price or whatever. So we're going to add a random term that's parameterized as a normal distribution with a mean of 0 and a standard deviation of 10. Okay, so that might actually add to the quantity sold. It might actually subtract more from the quantity sold, because it's normally distributed, and a mean of 0 means we might be above 0, we might be less than 0. Okay, so all those 3 sort of components go together to represent the quantity, the number we sell. And then finally, there are some fixed costs. We have to pay for the facility we use to make the battery chargers, or maybe we pay for the retail space in which we sell them, and so forth. And that fixed cost, fixed not in the sense that we know exactly what it is, but fixed in the sense that it doesn't matter how many we sell for how much the cost will be. So that fixed cost is uncertain, but it's normally distributed with a mean of 30,000 and a standard deviation of 5,000. Okay, so we're going to take all of this information, put it into an Excel model, use this information to parameterize some random functions, some random variable functions, and then compute from that profit. Okay, so how much profit do we make? That is, figure out how many units we sell, the price we sell them at. That's those two things multiplied will be revenue. The quantity sold times cost. Unit cost is sort of variable cost. Then we also have fixed cost. So if we take our revenue minus our costs, that's how much profit we make. So we're mainly interested in what's the distribution of profit given these distributions of parameters for price, cost, quantity, and fixed cost. Okay, so go to Excel. I might have to rely on you to remember some of this for me. So we'll start with unit price, and I'm just going to remind myself that was triangular distributed. The min was 18.95, the
24.95
and 26.95, right? Okay. So this was the min, this was the expected, and this was the max for our unit price. Okay, our unit cost, okay, was a minimum of $12 and a maximum of $15. Right? There's no expected value because the unit cost is uniformly distributed. That is, every value between 12 and 15 is as likely as every other value between 12 and 15. Okay. So that will be parameterized with just two things, the minimum and maximum. So then we had our quantity, the random part of our quantity anyway, which was normally distributed. Okay, and that has an expected or mean value, okay, which was 0, and a standard deviation representing how much different above and below 0 might go, which was 10. Okay, so that's the random part of the quantity sold. Not all of the quantity, but the random part of it. And then finally we had our fixed cost, which had a normally distributed 30,000 mean and $5,000 profit, or $5,000 standard deviation. Okay. So to make our model make a little bit of sense, I'm going to format these numbers the way they should be, so the things that are currencies look like currencies, and so forth. Okay, so that was part of our model. There was a few other parameters that were not random or not uncertain, and that was the base quantity, which was 10,000, and the quantity price coefficient, that is, the thing we multiply by price that we're going to add to the base quantity, which was negative 250. Okay, so those are just a few other parameters. I'll call this set of things up here, our uncertain parameter values. And then we have sort of our certain parameters, that is the part of the parameters that we know something about. So then I'm going to have just a section to compute some calculations. So the first thing we probably need to calculate is quantity, that is how many things do we sell? Oh, I'm sorry, not calculations. Calculations and we'll call it random variable selections. It's a long description, but I want to make sure it makes sense what we're doing. So the first thing we need to do is select what the unit price is going to be. Okay. Now there's a few ways you can do this to put in these random distribution functions. For the unit price, we know it's triangular and it has these three parameters that we put in up here. So if I'm going to put in that function to randomly compute a triangular value, from that distribution in this cell, B13, the easiest way to go about that is from the Analytics Solver platform tab. There's a button called Distributions. Okay, meaning random variable distributions. And there's quite a few of them here, okay, or quite a few categories of them. Mainly, the three we're going to use for this problem are all under common, okay, where you'll see normal, you'll see triangular, and you'll see uniform. And you'll see 8 others or 7 others that we did not talk about that might come up in the real world, but not in this class, okay? So we're not going to worry about what a beta or gamma distribution is or why it is the way it is. We're just concerned with normal, triangular, and uniform here. And in this case, we want to select triangular. So that brings up the probability distribution graph to represent a triangular distribution with some values already filled in. However, we know what value for min, likely or expected, and max we want to use. In this case, for min, I'm going to choose this little, I don't even know what this button, how to describe it, with the little red arrow on it, to say for the min value, I actually want to use cell C3. Okay, that's the minimum of the triangular distribution I want to use for my unit price. Okay, and the likely value is going to come from cell D3, and then if you want to, you can just type in, well, if you type it right, there you go, E3. Okay, so that basically says, here's the triangle distribution for unit price. That is, unit price will always be between $18.95 and $26.95, with the most likely value being $24.95, values we had in those cells. And every other value sort of have a probability represented by the blue line or blue shade at that point. So I can click Save, and you'll see here in B13 what it's done is it's put in an equation using this PSI triangular function using min, expected, and max as the 3 parameters. Okay, you could have typed this in just like this if you had wanted to. Okay, generally it's easier to use the distribution button. It kind of helps you, it leads you through the steps and shows you what to choose. You don't have to memorize what order to put the parameters in. Okay, all right. And right now it's randomly picked a value of 21.11. Right? It's not necessarily important, just the currently randomly selected value. Okay? So from price, we can actually compute quantity. And quantity is going to be an equation. We're going to take the base quantity, 10,000. We're going to add to that this coefficient parameter multiplied by the selected price. Okay, so once we've selected a unit price, we multiply that by negative 250, add that to 10,000, and then we're going to add to that this normally distributed random part for quantity. And I'm going to type this one in, not because it's better or easier, but just to show you how you do that as well. So PSI normal is the function for a normally distributed random variable. The first parameter is the expected or mean value. The second parameter is the standard deviation. Okay, so here's the equation for computing quantity, the number of units we'll sell. In this case, C9, 10,000, plus C10, negative 250, multiplied by B13, the randomly selected unit price, okay, plus PSI normal, mean of 0, standard deviation of 10. So once I've entered in, once you modify this Excel sheet, it recomputes values. So now we've randomly picked a unit price of 25.64, a quantity of 3,589, and so forth. Now, I'm not going to be concerned that the quantity is a fractional number here. In the end, it won't matter very much because we're going to randomly select so many different values that, trying to round it or not isn't important. If you wanted to, you could use a function to round this to a whole number, okay? And you'd have to choose to round up or down or round sort of the normal mathematical way or whatever. I'm not going to bother, okay? Just because in the end, that's going to be such a fraction. That's going to be such a small impact on the objectives or objective that you probably wouldn't even see a difference. All right, so now we have our variable cost. compute that. So the variable cost is just a uniformly distributed number. I'm going to use the distributions button again, go to common, find the uniform distribution to use. And there's only two parameters, the lower bound, which is 12 in C4, and the upper bound, which is in E4, if I wanted to just type that in. So that's the variable cost. So now we've selected that randomly, we've picked these values, and now we need to do fixed cost. Fixed cost is normally distributed. Let's use the button for that. Distributions common normal. And we'll select the mean as cell D6, the standard deviation as cell, move this out of the way, as cell F6. Okay, so here it's showing us the distribution of values. It's already figured out that it can represent those as thousands. So the mean is 30,000. Standard deviation is 5,000. So there's, again, mathematically a 68% chance that the fixed cost will be between 25,000 and 35,000. There's a 95% chance it'll be between 20,000 and 40,000. There's a 99% chance it'll be between 15,000 and 45,000, and so forth. And you could actually verify that with these values up here if you wanted to. Okay, so that computes all the calculations of the randomness of the model. So now we just need to compute our objective, which is profit. Okay, so profit is the unit price times the quantity, that's revenue, minus the variable cost times quantity minus fixed costs. Okay, so I'm just computing all that in one equation, one step. Profit. You could break it down into computing revenue and costs, and then profit is revenue minus cost, but that's what I've done here. Just one step. Okay? Alright, so let's format the values that need to be currencies to look like currencies. I'm going to highlight the objective cell, as I've done for optimization in the past, just to help us understand this is what we're interested in. Okay? The last thing you have to do, okay, for simulation is tell Analytic Solver Platform that this cell B17, where I've computed profit, is the output cell that I want to capture all the simulated returns of. That is, every time I simulate, I want to capture what value of profit it computed, and so I can graph and do some statistics on that. Easy way to do that, select the cell, go to the Results button on the Analytic Solver Platform tab, and just say the output is in the cell. Okay, it's in the cell that I've now selected, B17. And you'll see all that really does is add to the cell equation plus PSI output parameters, or parentheses. Okay. So again, you can type that in, or you can use the method I just used where I selected the cell and used the Results button. Either way is okay. So now I can click the Simulate button, or simulate and run once, and it will bring up, in this case, this is the simulated profit. Okay, so the profit is the output cell, the simulated profit across, by default, 1,000 simulations. So we can look in this and answer a few basic questions. One is, what's the expected, sort of most likely or average profit that we make? And that would be the mean. So we somewhere here in the $10,000 range, and if you look over here, it's $10,732.76. So on average, given all these model parameters and the uncertainty that we represented, we'd expect to earn about $10,732 in profit. Okay. However, we can also ask, what's the worst case? What's the minimum profit we would make? And in that case, the minimum is actually negative $12,000. Right? right? So there's a chance, anyway, that we actually lose money. That is, our costs outweigh our revenues. High fixed costs, high variable costs, and maybe low revenues result in us losing money. Okay? And the worst case in those 1,000 simulations is a loss of $12,297.03, a negative $12,000 profit. Okay? Best case, highest profit, maximum, we made $33,000, $33,578.65. Okay? So those are just some of the very basic sort of results you could read off of this graph and these statistics. Expected value, average value, minimum and maximum, which would be your sort of best and worst case. Okay. We could also use the chart over here with its various percentages and things to ask about probabilities. So we might be curious, what's in the 95% case, right? What's our expected profit? And you can look at that in two different ways. One would be to say, with 95% certainty, what profit will we make at the lowest end? That is, there's only a 5% chance of making less than that, 95% chance of making more than that. And in that case, the answer would be negative $1,340. So I'm reading that off the sort of left-hand part of the graph up here, which says there's a chance that you make a negative $1,340 profit. If there's a 5% chance you make less than that, even, which means there's 95% chance you make more than that. Okay. On the flip side, you can say with 95% probability we make less than $21,740. So that's sort of the upper end. A 5% chance we make more than $21,740. 95% chance we would make less than it. Okay. And if we wanted to move those values around, we could. We could certainly type some in and say there's a 10% chance we make $19,270 or more. Okay, so there's 10% of the likelihood is contained at values above $19,270. Again, in those 1,000 simulations, those 1,000 simulated profits. Okay. Now, when you're doing your assignment, you will all get a different answer because your computer will randomly select different values than somebody else's computer. Now, they'll use the same distributions as you've set them up, maybe, but the actual values that randomly get selected could be different. So if I reran this simulation again, so let's just remember the 10% chance is $19,270. I'm going to force the simulation to run again. So again, run 1,000 simulations. And let's ask the question again, 10% chance. So now it's $19,290. Close, but not the same as it was before. If I did it again, I might get an even different answer. Less, more, somewhere close, more than likely. Okay? So I want to make sure you understand why that is and that it's okay that you and your friend, now don't compare your homeworks and cheat, but if you compare your homeworks to see if you're getting close answers, remember that when it comes to simulation, there's uncertainty and randomness involved. So you won't get exactly the same answers, okay, like you would for optimization or other thing or forecasting, okay. So in this case, it's very possible that 31 of you, submitting homework assignments, I get 31 distinct answers for every question, okay. Don't worry about my grading, I can figure it out, but that's okay, right? Now, if somebody gets $19,290 as a 10% chance and someone else gets $4 billion, well, that's different. That's probably wrong, but everybody should be roughly in the same neighborhood, okay? So if you are looking, or you do happen to simulate a second time, or you close and reopen the Excel and it recomputes everything, don't be surprised that you'll see slightly different numbers because it randomly selected different values. Okay. All right. Any questions about what we've done here, simulation? I just want to show you. So again, sorry, this is a little bit off the screen. So these are the values I was reading here. So a mean of $10,711 this time. Worst case, minimum profit was negative $14,000. Maximum, best case, $33,000 profit. The range between those two is $48,000. So there's a range of about $48,000 that we don't know where our profit will be. Okay. Most likely it's somewhere near the middle, somewhere near this $10,000 range. Okay, that's the bulk of the probability, most likely values. Okay, but it could go as low as negative 14,000, as high as 33,000 or so. If you close this screen, you can always get back to it by double-clicking the output or the objective cell again. Okay, and since I've already run the simulation, it will bring up the same values again. Okay, so it didn't resimulate, reselect random values. I see the same numbers as I did before. Okay. All right. Any questions?
It's got a huge downside.
Well, okay, so explain what you mean. The downside to simulation.
Well, I just mean, I was looking at that and I was thinking, well, the amount that you could lose, even though, there's less than a 5% chance, according to statistical theory, they say that events like Black Monday and all these different stock market crashes couldn't have happened in 27 million years or something.
Sure.
But
they do.
Black swans, they talk about how there are fat tails to all these distributions.
Right.
So.
Yeah, so that brings up a good point. I'm going to actually select as the value I'm curious in as 0. So what's the probability that we break even? In this case, it's simulated. There's a 5% chance we make less than $0. That is, we lose money. 95% chance we make money. It's much more likely that we make money, right? Obviously. But there's a non-zero and maybe a decent chance you'll lose money, right? And depending on, so again, this is where you would take simulation as a tool to help you make a decision about, is this a worthwhile business to get into? If there's a 5% chance that I do all the work and then I end up owing more money than I make, I lose money. Maybe 5% is too risky. Maybe it's not. That's a human decision to layer on top of the tool of simulation that helped us come to that understanding or come to that realization.
Oh, yeah. I don't disagree with that. I mean, if I were Richard Branson, I would definitely do this. Because,
I would, if I was an investor, I would do this and several other things.
Right.
Which all have a 5% chance of losing money, because the likelihood they all lose money is really small. And so even if one loses money, I can offset it by the others and blah, blah, yeah. As an investor, you might do other things. But at least in this case, it is what it is. But we've simulated. We can answer the question. If somebody said, this is what I think price, costs, quantities, and all this work like, they can ask the question, what's the probability that I invest in this and I lose my money, that I make less than I put in? And the answer is 5%. There's a 5% chance, or 1 in 20 chance, you lose money. Okay. Well, that takes care of simulation. That actually takes care of the whole course. So, I think what I'd like to do, let's take a very short break, and then we'll come back and I'll go over and just generally review what we've covered throughout the term, okay, starting from week 1, and kind of give you some, tips, at least, on what to expect on the final exam. Now, final exam's next week. Between now and then, you'll have an assignment number 6, last assignment, and it'll cover simulation. Okay, and most likely it'll look something like two distinct problems, described. I want you to build an Excel model, put in all the parameters and the random variable parameters to compute, and then answer questions like what we just answered. What's the expected profit? What's the minimum and maximum profit? Or minimum profit could also be loss, right? So what's the maximum loss or the worst loss? Or what's the probability of a loss? Or what's the probability of making more than, say, $10,000 profit? And so forth. And you would have to use the techniques we just demonstrated, the charts and the ways you can read those statistics and manipulate the graph to compute those probabilities and values and answer those questions. Okay, so that will be assignment 6. We'll come back in a few minutes after a break and talk about the final exam and what to expect there.